Greetings to you. You are most welcome to Physics with Ben. Don't forget to subscribe and click the notification bell so as to get prompt notification anytime a content is uploaded on this channel. God bless you. In our previous video, we have looked at the topic waves optics and also the general properties of light waves: reflection, refraction, diffraction, interference, and polarization. I have done almost all the videos on reflection of light at plane and curved mirror surfaces and also all the calculation theorem. Kindly click in the description box below and you will get the video links to all the videos on reflection of light at plane mirror and curved mirror surfaces. In today's video, I want us to look at a brand new subtopic, refraction of light through rectangular glass block. Refraction of light through triangular glass prism. Before us here is a guide to help us organize ourselves in this lesson. So we're going to be following them serially down straight. So, first things first, what do we mean by refraction of light? Before me here is a glass of water. You see that? I dip this in, you see that it has bent. So, it is because the meter rule, the 30 cm rule has entered into a media of different density, hence the bending. We can call the up one the air media and then the down one the glass media. So that is refraction in nature. So what do we mean by refraction in the language of physics? Refraction is the bending of light rays as they travel from one media to another of different density, thereby changing the direction of travel of the light ray. The change the direction of travel of the light ray is because of the different densities in the two media. And so we want to look at the second option, the second list item on the list, ray geometry of refraction of light through rectangular glass block. Before me here is your rectangular glass block. And before I continue, I want you to know that all mirrors, be it plane or concave mirror, they all reflect the rays of light. While all glasses, rectangular, triangular, by convex lens, by concave lens, they all refract the rays of light. So I want to draw the geometry of this mirror, of this glass, and then tell you what and what is obtainable. So let's suppose that this is a rectangular glass block. The drawing is not properly, but you can do it more appropriate in your book. Let's label this block A, B, C, and D. How do we represent the refraction of light through this block? Very simple. The next thing is to draw a normal perpendicular to surface AB. We draw a straight line here called the normal. Perpendicular, let's call this N, let's call this NO. NO is our normal drawn perpendicular to the surface. Now, I want to correct something. A ray of light will be coming, this is the air media, and this is the glass media, and then this is also what? The air media. The air media has a density, a refractive index of 1.33 thereabout, and then the glass media has a refractive index of 1.5 to 1.7. That is the range. The range for the refractive index of the glass is from this to this, and for air is from this to this. Meaning these guys don't have the same densities. So, if a ray of light is coming from the air media, this is how it is drawn. Now, supposing that there was no glass media here, this ray of light was supposed to pass through here with this dotted line. That's it. But because there is a glass media here, the ray of light will bend. But then the angle of inclination, this to this, is called the incident angle, and this is the incident ray. The incident ray, the what? The incident what? Angle. So the ray of light will bend. This bending is what we call refraction. The ray of light will bend, and then you put another arrow here. And then at this surface, you draw another normal perpendicular to this surface, ACD. So the light ray will also go out, and then it will emerge. So there are two angles here. That this angle is, we can call your R1, and you know this angle is the same thing with this angle. So this is your R2, and then this angle is called your E. The incident angle, the refracted angle, and the angle of emergence. So this is the incident ray, the refracted ray, and the emergent ray. This is how we represent refraction of light through rectangular glass block. The next thing we want to look at on our item here is laws of reflection and equations that are involved in this diagram. There are basically two laws of refraction, just like we have two laws of reflection. The laws of refraction number one, the laws of refraction number one states. I will be using this diagram to explain the first law. First law of refraction. Laws of what? Refraction. The first law states the incident ray, the refracted ray, and the normal, they all, I take it again, the incident ray, the refracted ray, and the normal are the points of incidence. Look at it here. They all lie on the same plane, AB. Law number one. Law number two is what we call Snell's law of refraction. Law number two states the angle of the ratio of the angle of incidence to the ratio of the angle of refraction, one of these, is equal to a constant for a given pair of media. I take it again. The ratio of the angle of incidence to the angle of refraction, you can choose any of these, is equal to a constant for a given pair of media. What that law says mathematically, which I call Snell's law of refraction. What that law says mathematically is given as what? Refractive index of air with respect to glass. Refractive index of air with respect to glass is equal to what? The ratio of the sine of angle of incidence to the ratio of the sine of angle of what? Refraction. That is Snell's law of refraction. I believe we are moving Snell's law of refraction. I want to use this particular medium to generate all the possible equations you need to know while dealing with this particular topic. So let's move straight to the point. We have seen from this that our refractive index of air with respect to glass is given as the sine of I to the sine of R. We call it Snell's law of refraction. Now, I want you to know that light rays in the previous topic I told you is an electromagnetic wave. And so it means that light rays travels with the speed of light. And hence, they are permitted to make use of the general wave equation, given as V is equal to what? Lambda F, where this V is simply the speed of light, 3.0 times 10 raised to the power 8 meters per second. Or this V is also known as C equals to what? 3.0 times 10 raised to the power 8 meters per second. That is the speed of light. And so this light is traveling from this medium with a speed of light, and it enters this medium and then it goes out. Now, there is something I want you to know, that when a ray of light is traveling from a medium, from one medium to another, the speed of light and the wavelengths of the ray of light will change because of the different densities in the two media. However, the frequency with which the speed of light is traveling with will not change, will remain constant. For this reason, we are free to say from Snell's law that the equations of light rays from what? Air to what? Glass is given as follows. We say that refractive index of air with respect to glass is given as what? Sine I over sine R. And this refractive index is the same thing as what? The same thing as what? V, that is V1, or can say V air over what? V glass. Which is the same thing as what? The wavelengths of air, the frequency, and then the wavelength of what? Glass. In this case, this will strike out this. Sorry. This will strike out this. And then we are left with A and G is equal to what? Sine I over what? Sine what? R. Which is equal to what? VA over what? VG is equal to what? Lambda A over what? Lambda what? G. That is wavelengths in air media over wavelengths in glass media. Velocity of the ray of light in air media towards velocity of light in the glass media. That is the meaning of this equation. So these equations are very, very important. Now I want to know something, that when you have something like this, this is the meaning of this particular equation. What's the meaning of this? It implies that air to glass is equal to what? Sine I over what? Sine what? R. You can call this your equation number 1. It also means that this is equal to this is equal to this is equal to this, and this one is equal to this. So if I can use this space, it implies that our A n to glass is equal to what? The sine of I over what? Sine of R Equation 1. Also, A to glass is equal to what? VA over what? VG. We call it equation number 2. Also, air to glass is equal to what? Lambda A over what? Lambda what? Lambda what? G. Is that all? We call it equation number 3. Also, what's the meaning of that? It means that sine of angle of I over sine of angle of R is equal to what? VA over what? VG. We call it equation number what? 4. Also, the sine of angle of I to the sine of angle of what? R is equal to what? Lambda A divided by what? Lambda what? G. Call it equation what? Number 5. And then finally, equation number 6. Equation number 6, we say that VA over VG is equal to what? Lambda A over what? Lambda what? G. Equation number what? 6. These are the possible equations you must come across with when you are dealing with refraction of light through rectangular glass block, and the light ray is traveling from air to glass media. Equation 1 down to what? Equation number 6. What if it is from glass to air? Let's change it. From glass to what? Air. From glass to air. What are you supposed to have? I believe this is very, very simple. Before I continue, I want you to know that what you have in our textbook is this. You will have V1 over V2, lambda 1 over lambda 2. They mean the same thing. That one means they mean maybe air media or glass media. 1 mean 1, 2. The one here means refractive, mean air media, and then the other one here means what? Glass media. They could choose that one to be your glass media or the two to be what? Your air media. But I'm using this for the sake of convenience. We see A here means air media and G would mean what? Means glass media. So let me quickly change this and do the rest. So when the light ray is traveling from air to glass, from glass to air, this is what you have. You change this as what? GNA is equals to what? The sine of R divided by what? The sine of what? A. The sine of I, sorry. Please take note. A good number of students get it wrong when it comes to this. Be mindful of where the ray of light is coming from. Is it from air? Is it from glass? Be very, very careful. So when this happens, everything will have to become what? The opposite. In this case, what do you have? You have from V is equals to lambda F, which is congruent to what? VA is equal to what? Lambda A F. Also VG equals to what? Lambda what? GF. This is the meaning of this particular equation. So we are going to customize it to fit into that. So now what we have here becomes what? VG over VA is equal to what? Lambda G over lambda A. Yes. This cancels this, which means what? Lambda G over what? Lambda what? A. So what you have here is just to change everything. So here you change this to your R, this to G, this to A, this to I. That is from glass to air. This to G, this to A, this to G, this to A, this to G, this to A, this to G, this to A. This to R, this to I, this to G, this to A, this to R, this to I, G, and A. And then you are good. So these are all the equations you need in doing all the calculation concerning refraction of light at through rectangular glass block. Next thing, I believe we are through with number 3 item. We want to look at number 4 item, verification of Snell's law through experiments. Now, from here, you know that this is Snell's law, right? Good. Through experiment, how is this verified? How is Snell's law verified through experiments? You know that from here we can cross multiply and we'll have our sine I equals to what? A G sine R. This looks like a straight line equation, right? Where you have your y is equal to what? N what? X. Where n is the slope. And in this case, this refractive index is the slope. So you may run an experiment having several of these, which is what I'm going to do in the subsequent videos, where you put pin 1, pin 2, pin 3, pin 4, and then you do all the geometry to get all the angles involved. And in that case, you are asked to plot a graph of sine I against sine R. A graph of sine I against a graph of sine I 0, 0 against sine R will give you a straight line graph passing through the origin. Here is change in sine I, change in sine R. So the slope of that graph must give you a value within the range of 1.5 to 1.7. And that slope has no unit, because the refractive index of a glass media is a dimensionless quantity. So if you plot your graph and you are having a value of 1.4, you are having a value of what? 1.8, that experiment is totally wrong. Your value must fall in the range of 1.5 to 1.7. So this is how Snell's law is verified through experiments. Here you have increase, this is constant, increase, increase, decrease, decrease, increase, increase, decrease, decrease. Direct proportion between sine I and what? Sine R. So the next item on the list is the critical angle and what? The total internal reflection. I am trying to hit a point, subtopic, where you always see questions in the external exams. And so please stay with me to the end and pay maximum attention. Total internal reflection is something you need to know, because that is the principle with which fiber optics works with. There's a topic called fiber optics. Questions in that topic keep coming every year. So if you don't understand critical angle and total internal reflection, you can't, they will ask you, state and explain the working principle of fiber optics. So let's write. We want to look at critical angle and total internal reflection. Critical angle and total internal reflection. I am going to use a diagram to explain the critical angle and total internal reflection. Back again to this diagram again. Our rectangular glass block, our normal NO, A, B, C, and T. Now, what do we mean by critical angle? Critical angle is simply defined as that angle of incidence from a denser media that makes the angle of refraction between the interface of air and glass to be perpendicular to the normal. In simple terms, this is what I mean. A ray of light traveling from a denser medium will incidence this place, and the angle is always to the normal. Take notes. In the other diagram, I drew something like this. The incident angle is always to the normal, not to the surface. Please take notes. So in this case, the critical angle C will also take reference to the normal, although it is traveling from glass to air medium. Now, what happened here is that at critical angle, the angle of refraction is perpendicular to the normal. So this angle with which the angle of refraction is perpendicular to the normal is what we call the critical angle in physics. Now, I was saying something that you have A N G is equal to what? Sine I over what? Sine R. Now, when the ray of light is traveling from air to glass, you have to reciprocate this by saying G refractive index of glass with respect to air becomes what? The sine of R over what? The sine of what? I. Now, let's step this down. We have GNA is equal to what? Sine R over what? Sine I. But in this case, our I is equal to what? C. In this case, this I is the same thing as what? The incident what? Angle. So our I is equal to what? C. And then what again? Our R is equal to what? Sine what? 90 degrees. This angle is what? 90 degrees. So what do we say? This implies that refractive index of glass to air is equal to what? The sine 90 degrees divided by what? Sine what? C. Sine C. Sine 90 will give you what? 1. So we say that what? We say that GNA is equal to what? Sine 90 will give you 1. So 1 over what? Sine what? C. But we said that the refractive index of glass, be it air, of glass material, be it air to glass to air, or air to glass, must fall in the range of 1.5 to 1.7. That was the statement we made here. So in this case, we are choosing what? This. So we say that, but what? GNA is equal to what? 1.5. So this implies that what? 1.5 is equal to what? 1 over what? Sine what? C. You cross multiply so that you have your 1 is equal to 1.5 times what? Sine what? C. Divide both sides by what? Both sides by 1.5, 1.5. This go. So your sine C equals to what? 1 over what? 1.5. If you do that correctly, what do you have? You have 1 divided 1 divided by 1.5, that will give you 0.666. So you have sine C is equal to what? 0.6666, recurring decimal. So you take the inverse of sine. So you say sine inverse. Sorry, you divide both sides by sine, which is the same thing. So that your C is what? Sine inverse of this. So shift sine inverse of that will give you 41. If you do that correctly, your C, sine inverse of 0.666, if you do that correctly, you're going to have 41.8 degrees. 41.8 degrees. Therefore, the critical angle for a glass medium C is what? 41.8 degrees. So C is approximately 42 what? Degrees. This is a critical angle. Clap for me. So, what is total internal reflection? Total internal reflection occurs when the angle of incidence from a denser medium to the normal exceeds the critical angle. It means that when I is greater than C, total internal reflection occurs. And this is a principle with which fiber optics works with. In this case, if we shift this line slightly above C here, more than maybe 43 or 45, 46, then we are going to have what is called total internal reflection. When I exceed C, you have to do like this. So in this case, the glass medium behaves like what? The plane mirror surface. To this, we have come to the end of this video. The next video, I will look at refraction of light through triangular glass prism and then do some little calculations. Don't forget to subscribe and share this video to those that need it. God bless you. Bye-bye.